Time synchronization. Time synchronization is crucial in any Linux system, especially in environments where multiple machines interact. If time drifts out of sync, it can lead to issues in distributed systems, troubleshooting logs, and even security problems. The NTP or Network Time Protocol is a system designed to synchronize the time between computers over a network. Maintaining accurate system time is important in various situations, from databases to clusters. In openSUSE lib, we use Chrony as the NTP Network Time Protocol service. Chrony is fast, accurate, and particularly useful on systems with intermittent or unstable connections. Since openSUSE lib 15, Chrony has been the default NTP implementation. Chrony is composed of two parts, Chronyd, a daemon, and Chronyd, a command line tool for monitoring and modifying Chrony D. Let's confirm that Chrony already installed on our system. We can do sudo zipper info and Chrony and we press enter. Now let's verify that the service is running. Sudo system control status and Chronyd. Okay. Now let's check the NTP configuration from Yast and let's go and write Yast here and we enter our root password. And from the network services, we can find NTP configuration. And let's go through the options there. Here you have the start NTP daemon. And this you can choose when to start the NTP daemon. We have only manually. This will require you to start the Chrony daemon manually. The second one, synchronize without daemon. The system time will be periodically updated without a constantly running Chrony daemon. The third one, now and on boot. This option starts Chrony automatically on boot, which is recommended setting. You can also configure the source type as either dynamic or static. If you are using DHCP, choose dynamic. Otherwise, static is good for predefined servers. Finally, you can add, edit, or delete time servers from the list. Make sure to use reliable sources. For an example, pool.ntp.org. Like for an example, we can go here and we can choose public. And from here, we can get accordingly here all. You can go through all the sources for NTP. Okay. And again, make sure that you are using a reliable sources like, as we said, pool.ntp.org or maybe SUSE.ntp.org. Now let's manually configure NTP. Chrony is configured using the /etc/chrony.conf file. This file controls how your system syncs time. Let's edit it to include a few NTP servers for more reliable time syncing. Sudo ei etc chrony.conf. Look for the line that begins with pool and replace or add reliable NTP servers of your choice. Here, I'll take this copy and we can add this and another one, but this time I will use openSUSE.spool. Okay, and we can add it like that, or we can add it like this and another pool. Okay. And also you can specify multiple servers like this. You can say server 1.openSUSE.pool.ntp.org. So don't forget, after editing in chrony.conf file, you have to restart the service of Chrony. So let's restart it. restart Chronyd service. Okay. And there is a note warning in the official documents of openSUSE. Be careful not to enable both Chronyd service and Yast-time sync service at the same time, as they can conflict with each other. So be careful about that. Now let's talk about commonly used options and directives, like the iBurst we saw before in the configuration file. iBurst, when a time source is unreachable, iBurst sends a burst of requests to the server at a faster rate, typically 4 to 8 requests within the first few seconds, to speed up the initial synchronization. Once the server responds, the polling rate returns to normal. This is useful to quickly sync the time after the machine is turned on. Another one is pull interval. The pull option controls how frequently the time server is pulled for synchronization. The value represents the algorithm base 2 of the interval in seconds. For example, pull 3 would result in pulling every 2 power 3 equal 8 seconds. We have another one, max pull and min pull. These options define the minimum and maximum pulling intervals. For example, if you set minimum pull 6 and maximum pull 10, the pulling interval will vary between 2 power 6 equal 64 seconds and 2 power 10, which is equal 1024 seconds. Lastly, we have local stratum. Specifies the stratum level for the local reference clock. The stratum level indicates the distance from the authoritative time source. Stratum 0 represents the most accurate clock, for an example like GPS or atomic clock, while higher numbers indicate less reliable time sources. Setting local stratum 10 tells Chronyd that the local clock is a last resort fallback source. Example like local space stratum space 10. Now that Chronyd is running, let's verify that it is synchronizing correctly. Run sudo Chronyd C tracking and hit enter. The Chronyd tracking command provides detailed information about the current status of the Chronyd time synchronization on your system. Chronyd is a versatile implementation of the Network Time Protocol (NTP) and is responsible for keeping your system's time accurate. The output of this command helps you understand how well Chronyd is performing and how synchronized your system is with the configured time sources. Let's break down the output. Reference ID. This is the identifier of the NTP server or other time source that the system is currently synchronized to. It shows either an IP address or a host name, helping you identify the specific time source Chronyd is using. If the time source is reliable, you can expect better synchronization accuracy. And stratum. The stratum is the distance from the primary reference clock. Stratum 1 is a time source directly connected to an atomic clock or GPS. Stratum 2 servers get their time from a Stratum 1 server, and so on. Lower stratum values closer to 1 generally mean more accurate time. In this case, 4 means the system is getting time from a stratum 3. Reference time, UTC, Universal Time Clock. This shows the last time Chronyd received and processed a time update from the reference server in UTC, or in another word, Coordinated Universal Time. This helps track when the system last synchronized with the time server. If this value is old, it might indicate connection issues or that updates are too infrequent. Then we have system time. This shows how much the system clock differs from the NTP synchronized time. So here in this case, we have this number seconds slow of NTP time. Uh, the closer this value is to 0, the more accurate your system's time is. A small difference is normal and expected as clocks are never perfectly synchronized. Last offset. This represents the offset between the system clock and the reference clock from the last update. A positive value means the system was ahead, and a negative value means it was behind. This value helps you see the recent drift in the system clock relative to the reference. Chronyd adjusts the system time based on this value. The RMS offset. This is the root mean square, or RMS, of recent offsets, which gives a measure of how stable the system clock is. The lower this value, the more stable your system time is. Higher values indicate more fluctuation in the time synchronization accuracy. Frequency. This is the correction that Chronyd is applying to the system clock to compensate for its inherent drift. The frequency adjustment is measured in parts per million. In this case, the system clock is running. Uh, Here, the frequency. Yeah, it's a little bit slow by this number 11.609. This shows how much Chronyd needs to adjust your system's clock. A high value could indicate that the system clock is less accurate or that there is a hardware issue. Then we have the residual frequency. This is the remaining frequency error after Chronyd has made the frequency adjustment. It shows how well Chronyd's frequency correction matches the system clock's drift. A, re- a residual frequency close to 0 indicates that Chronyd's corrections are working well. Large residual mean there is still some error left to correct. Skew. This is an estimate of the error in the system's frequency correction, showing how much the frequency is fluctuating. It is measured in ppm. Lower skew values indicate more stable frequency corrections. Higher values suggest that the clock's drift rate is varying more. Route delay. Shows the round trip time it takes for a request to reach the NTP server and return. It is essentially the network delay between your system and the time source. A low route delay means that your system is close to the NTP server, network-wise, which can improve the accuracy of time synchronization. Route dispersion. This measures the maximum error that could exist between your system's time and the true NTP time due to network delay uh, or clock drift. A lower dispersion value indicates higher confidence in the accuracy of your time synchronization. Update interval. This is the interval between successive time updates from the reference source. Chronyd dynamically adjusts this interval based on the system's stability. If your system is highly stable, the interval can be larger, hundreds of seconds. If it is less stable, the interval might shrink. Leap status. This field indicates the leap status of the system clock. Leap seconds are occasionally added or subtracted to keep UTC synchronized. The possible values are normal, no leap second scheduled, insert, a leap second will be added at the next midnight. Delete, a leap second will be removed at the next midnight. Not synchronized, the system is not synchronized with any time source. Normally, will be set to normal, indicating that there are no leap seconds pending. You can use Chrony, the command line tool, to monitor and configure the Chrony daemon at runtime. You can run Chrony interactively by typing Chrony and entering commands at the prompt, like for an example, sudo Chrony and press enter. And we can write activity. This will give you the status of NTP sources. You can also run the same non-interactive commands. So let's exit from that queue and we write again activity. Just remember, changes made with Chrony are not permanent. If you need to make permanent changes, edit the file /etc/chrony.conf. Okay. Sometimes the system boots without a network connection. Chrony will keep trying to connect to the time server in increasing intervals until successful. You can set time servers to offline mode until the network is up using this configuration in the file sudo vi etc chrony.conf. And let's say for an example, this one, server openSUSE.pool.ntp, you at the end here of line, okay, and save the file, and don't forget to restart Chrony service, Chrony service. And after the system is already booted, you can run this command Chrony C online, and the IP or the host name of the for the server NTP server openSUSE.spool.ntp.org. Okay, that's for it's like dynamic time synchronization at runtime. You can configure it like that if you know that you have some kind of network issue while your system is booting. Now, to view the status of all your NTP sources, you can use sudo chrony c sources -v. This gives you detailed information about each source, including how frequently it's queried and the current offset. That's Chrony. It ensures your system is always synced with the with accurate time, which is vital for server management, especially in enterprise or distributed environments.